Okay, in this question you're given some information about a triangle, but you're not given a diagram. So guess what? Step 1, try and draw the information that they've given you. Now if you are well rehearsed, you'll spot from the problem where it says find the two possible angles of C. This is called the ambiguous case of the sine rule. This is where there are two possible answers for the given information. It's the only time when you're solving a triangle problem where there are two possible answers. The ambiguous case of the sine rule. And when you're drawing an ambiguous case of the sine rule, it should look a bit like this. So you put the angle you're given at the bottom left like that. Just trying to stick to this every time it works. The length that you know goes up the diagonal. And make sure you get your letters correct. I've been careful to have A and B the way they are. And then we're told that the third side, the one that we don't know anything about yet at all, is 16 centimetres. Now that can either be here or here. We don't know which. Both are valid possibilities. So we're either trying to find that angle there, which I'm going to call C, or that angle there, which I'll call C dash, or C prime. Okay, usually when you solve sine rule, it gives you this one first. It gives you the acute angle. And you've got to think about how we're going to use that to work out this other angle. I'll come to that in a moment. Right, let's set up sine rule. Sine rule works with opposite pairs, so a side opposite an angle. And if you've got a pair that's complete, so in this case we have an angle and opposite it is a side, actually either of these 16s, that's a complete side angle pair, and you can use that. If you've got one of those, you can use sine rule. We then have an incomplete side angle pair, which is the 20 and its opposite angle, which is one of the red or green angles. So sine of unknown C, this one, over 20 is equal to sine of 45 over 16. Rearrange that, times both sides by 20, and then shift sine both sides, and we get 62.1 degrees. Now think about how you'd work out the green angle given that. Well, look, this is actually an isosceles triangle, isn't it? So we know that this little angle here is equal to the red one. So then we can just do 180 minus that to get the green one. And there we have our answer. Okay, part 2, same triangle, but this time we're given the area, find BC. Well, you will hopefully remember this formula for the area of a triangle, half AB sine C. But it's equally true, if you label up the triangle differently, that the area is half BC sine A, or half AC sine B. All of those are correct and give you the area of the triangle. The one we want in this case, since we know the angle B, is that one there, sine big B. So I'm going to set that equal to the area we're given, substitute the information we know. So we know that, well, little a we don't know, because that would be opposite big A. That's the length of this line, which we don't know. C, and that's what we're trying to figure out, isn't it? We're trying to find BC, so we're actually trying to find this little a. Little c is 20, because it's opposite big C, and big B is 45, so set that up there. Now to simplify this, I'm first going to spot that we've got a half times a 20, so that's a 10. I've not changed anything else there, except I've recognised that sine 45 is root 2 over 2. I've then got another divide by 2 here, so I'm going to make that, so I've got a 10 and a half, so I'm going to make that to a 5. I can then cancel the root 2's, and we have our answer, little a, which is equal to the length BC, which is 15 centimetres.